Question number 6 is to graph and analyze polynomial functions. This is a simple one. Basically, here they have given the graphs of polynomial function and you need to just state where the real zeros are. So these are the type of questions. Look at this. Wherever it touches the x-axis, that's where the real zero is. So over here state the number of real zeros. How many real zeros can there be for this? It's only one. That's it. There is only one. Over here, let's see all the x-axis points, x-intercept points. Intercept in the sense when the graph touches the x-axis here. 1, 2, 3, 4. There are 4 real zeros. Now, if you're thinking, what's just for your extra knowledge, this is a linear graph. It is like y is equal to mx plus b. This is the form. Here, it is a polynomial power 4 quartic graph. X to the power 4 plus, it'll be x to the power 3 plus x to the power 2 plus x plus some number constant. Okay, this is highest 4, so maximum 4 roots may be possible. It might be other than 4, it might be 6 as well, it's possible, yes. And there are 2 imaginary roots and that might be possible. But this more likely looks like x to the power 4. That's the thing. But just look at the intercepts, you will understand. Here then we can see 1, 2, 3, and there is, see, this is not touching. So only 3. There is imaginary roots as well, sorry. This answer is 3 over here. What about this? Only 2. Now here there are at least 2 imaginary roots, because over here, since this is the thing, it is x to the power, it's not quadratic, it's more than quadratic, it's x to the power 4. But we can see only 2 real zeros. Why? Because there are 2 imaginary zeros. If you have the equation, we can check it out. But now you can see 2 real zeros will exist wherever it touches the x-axis. Here there were 3 points. And here 1, 2, 3. Here it is 1, 2, 3 again. 3 and 3. And okay, that's it. It's such an easy problem. I hope you're clear with this. Always remember the x-intercept points are the real, where that's the solution. Okay, whenever a graph touches the x-intercept, that's the solution of that graph, not the y-intercept. Okay, it's only the x-intercept. So we are just counting how many x-intercept points are there, and whichever number how many ever x-intercepts are there, so many real solutions are there. One last thing, what if this was your question? Then there is no real zeros, okay? If this is your question in the exam, it is not touching the axis at all, it's 0. Don't write 0, there are basically no real zeros. Only imaginary roots are possible for this. So that's the answers.